First step is to graph this cubic function. You might have forgotten how to graph it, but when you cube a number, what's 0 cubed? 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. What's 2 times 2 times 2? 2 times 2 times 2 is 8, which would be up here off the graph. What's negative 1 times negative 1 times negative 1? Negative 1. And then negative 2 cubed is negative 8. So it's this S-shaped curve through the origin, which you might have forgotten from Unit 1 or Unit 2. It was one of the cubic functions. We didn't spend a whole lot of time on it. So this is a good place to kind of just review what does it look like? What does x cubed look like? So here's what x cubed looks like. I'm not going to ask you this one unless it's a bonus on your test or you have a calculator maybe. But, you know, for your final exam, it would be nice to know that's a cubic function. But if I gave you the set of points, could you find the inverse? So 2, 8, 1, 1, 0, 0, negative 1, negative 1. What would this be? Negative 2, negative 8. So maybe take a minute to write that parent function down, and then flip all those points and see what it would look like if you graphed it. So we're using the points to find the inverse. So you're going to flip all the points. I'll flip them in a different color. So I'll do my inverse in purple. So these 3 points, because they lie on the mirror is y equals x. If they lie on the mirror, they're going to stay on the mirror when you flip it. So the 3 points in the middle are going to stay exactly the same. It's these outliers, the 8, 2, is showing you that your graph would be like way over here. So it snakes in this direction. So that purple graph, it still uses these 3 points, but it goes way over this way to 8, 2, and way over this way to negative 8, negative 2. So you guys are pausing on the coloring to do the notes, right? Adele, do you have a copy of this? I just don't want you to miss it. You're here. We're trying to do some practice on inverses. I didn't want the coloring to be a distraction. It was really like a have fun in the next 2 weeks. All right, what's the domain and range of the original function? All cubic functions can go forever up and down and side to side. So the domain and range are both all real numbers for my black pen and also for my purple pen because they're going forever side to side and up and down. So domain and range for the original are both all real numbers for a cubic function, and domain and range for the inverse is also all real numbers. Does anybody recognize the purple function? What would be the inverse of x cubed? What was the inverse for addition? Subtraction. Multiplication was division. What was the square root's inverse? X squared. So what do you think x cubed's inverse is? The cube root. So this is actually the cube root of x. Cube root of x is the inverse of x cubed. So kind of just tying together, hey, these are 2 parent functions that we've looked at once upon a time. What were those points then, and how do I find an inverse? More of like bonus. I want you to do a linear function for Friday, but you know, just wanted to throw that one at you. Parabola, we spent 2 entire units on how to graph a parabola and how to find the graph of a parabola. So I hope you remember the key points for x squared. Where was x squared's vertex? 0, 0, 1, 1, and negative 1, 1, right? Because when you square it, you get 1. And then 2, 4, right? 1, 2, 3, 4. This is my parabola. So this is the original function. And it says something strange. It says, let's restrict it so it has an inverse that is a function. Again, this is more like Algebra 2 Advanced or bonus, but I just want you to see it in case you're going to take pre-calculus. What does that mean? Well, when I go all the way back to the beginning, I think I put it on the front page, and I kind of didn't talk about it because I didn't want to confuse you. A one-to-one function is a function in which each y has only one x value. And a horizontal line test, which I'm kind of not really covering in here, but if the horizontal line can cross the graph twice somewhere, the function is not one-to-one, it will not have an inverse. So that's telling me that this graph would fail the horizontal line test. I could hit it 2 times with the horizontal line. So there's no inverse for this function. The reason is because when you tip this over the line y equals x, you're going to end up with a sideways parabola, and that's not a function, right? Fails the vertical line test. So it says, let's restrict this function so it has an inverse. So we're just going to kind of cover up this side of the graph. We're only going to take the inverse of the 3 points on the right, and you'll see why. If I take the inverse of these 3 points, this is 2, 4, 1, 1, and 0, 0. I'm just taking the inverse of half of the graph. Linear functions, you won't have to worry about this. Linear functions are always one-to-one. They always have an inverse. This was just a special case, pushing some of you the next step that, might see this in your mathematical future. 4, 2, 1, 1, and 0, 0. These 2 points stay the same, and then 4, 2 is over here. This purple graph is the graph of the square root of x. So this whole graph is x squared. But remember we said its inverse is the square root of x? This graph right here is the square root of x graph. So in order for there to be an inverse, you can't get a sideways graph that's not a function. This is a good one for domain and range though. The domain is only this black half of the curve. So x has to be greater than 0, and y also has to be greater than 0. I'm ignoring this side. Usually domain is all real numbers. We're going to say domain x has to be greater than 0 and y has to be greater than 0. And then on my purple graph, you can see x is greater than 0, y is greater than 0. So if if you're going to look over your notes before your test on Friday, if you just want to kind of write down this more of a bonus type question so that you're not freaked out that, oh my gosh, I have no idea what she just did. Come final exam, you're going to have to graph at least quadratics. You have to recognize cubic and cube root, but not for Friday's test. Friday's test, we're focusing on exponential and linear. All right, so these I also skipped on last week because they deal with a cubic and a square, but it just is practicing inverse functions. So let's just try them together. Remember, we just say that this is y equals to start with, and that way we can actually switch where x and y are. The strategy is to switch x and y in the original equation. So I write x equals the cube root of y minus 4 plus 1. We're doing some tough algebra today on this Monday. What do I do next to get y by itself? The inverse of adding 1 is subtracting, right? So I'm going to subtract 1 to the other side, so I get x minus 1. Subtract 1 from both sides. So x minus 1 equals the cube root of y minus 4. And then what did we say the inverse of the cube root is? X cubed, right? So I'm going to cube both sides of the equation to get rid of the cube root. And you got to be a little bit careful. We're cubing this entire side of the equation. So this side stays parentheses x minus 1 cubed. And then this side, now I just have y minus 4. Then my last step, the opposite of subtraction is addition. So I finish by adding 4 to both sides. So when you solve equations, you're really doing inverse operations the entire time. So your inverse function would be, I just switched the order, but y equals x minus 1 cubed plus 4 on the outside. And if you can understand that, then you're getting what we're doing with x and y and all these inverse operations. So let's do one more like that, and then I'm going to show you exponential. I'm worried about restricted, so it has an inverse. That means we're just looking at half of the function. We can just split x and y the same way. What would I do first to get y by itself? Add 5 to both sides. So I have x plus 5 equals y squared. What's the inverse operation to x squared? What would I do to both sides? Take the square root of both sides. So I get this whole thing is under a square root, and then this whole thing would just be y. So I could just write my answer. Y equals the square root of x plus 5. You know when you take a square root in a problem, you get plus or minus the answer, maybe from our square root unit? The reason why we don't have plus or minus is because we only have the top half of the curve. The minus would have given us this half of the curve. So the square root of x plus 5 is the answer. All right, the last one I wanted to look at is you just took a quiz on graphing. So you should be able to graph 2 to the x and 3 to the x, I hope, by hand. So could you make a table of values and try to graph 2 to the x and 3 to the x on this Monday? By making a table, all I mean is x, y, -1, 0, and 1, and then graph it. X, y, -1, 0, and 1, and then graph it. So graph each of these exponential functions. I want to show you what their inverse looks like. The point is we're studying inverses. Are you trying to tell you the quiz you left blank was on this? So in a minute, we might need help on how to do it, maybe. Okay, but this is kind of a big idea. Oh, so Sabrina, wait, did you do the graphing quiz then? Oh, you did the graphing quiz. This was the retake of that other quiz. Oh, okay, got it. Okay, so I may just hold off on that one for just a second. Start at 2? No, the y-intercept is always what? 0, 1. This is the regular parent function. There's no value out here like 6 times 3 to the x. So the y-intercept is 1 for both of these. The other strategy is when you have a multiplier. So where'd my answer key list go? I don't know. Oops, this one's growth. Do you need help on it? Okay, this should be growth. I'm gonna finish this so I can get this back. Okay, what you got? Yep, that's as far as I wanted you to go. Okay, so this is as far as I wanted you to go. Where'd my black pen go? Oh, here we go. So this should be 1/2 and 1/3, right? Because it's just the reciprocal of the original function. The y-intercept is always 1, and then this is just whatever the base is raised to the first power. So I always think about this is the reciprocal, this is 0, 1, and this is the base. Now, if this had been a fraction, it would make it a little bit different and flip-flop these 2 points, because a fraction raised to a negative exponent would give you a integer here, not a fraction. But for 2 to the x and 3 to the x, those are your key points. So that was kind of the first part you had to master for your quiz on Friday. It was just like, hey, that's what an exponential graph looks like. 0, 1, this one goes to 1, 3, and then this is at 1/3. So what would the inverse of these functions look like? So my 3 points are going to be 1/2 comma -1, 1 comma 0, and 2 comma 1. I'm going to draw this one in purple. So 1/2 -1, 1 comma 0, 2 comma 1. So this purple curve, this has an asymptote at 0. So this will have the opposite asymptote also at 0. This one's at y equals 0 for the black function, and this one's at x equals 0 for the purple function. That's what a log graph looks like. We're not going to get too in-depth in graphing log functions, but on the test I might ask you, graph the exponential function and its inverse. So that's what I'm looking for, that you've graphed the 2 functions. All you do is switch the x and the y. If you were going to graph the other inverse, it would be 1/3 -1, 1 comma 0, 3 comma 1. When you get to pre-calculus, there's a whole unit on log functions, applications, graphing logs. So at least you're like introduced to what the log graph looks like. But I'm not going to have you do any extensive graphing. You have to graph exponential. You have to be able to graph a log inverse. So here's my original function, here's my log inverse. The only other kind of baby step we're taking today into logs, we'll look a little bit more at logs tomorrow, but is to look at some new functions that you've probably never seen before. So you might think like, oh my gosh, I've never seen log with a base of 5 and then the number 25. Like, what does this mean? Well, at some point in your mathematical career, you saw this symbol for the first time, right? Or you saw this symbol for the first time. So it's just another symbol in mathematics. And actually, it's not as hard as it looks because it's all exponential. If I was going to rewrite number 1, I'm looking for the value that it is equal to. All you're going to ask yourself is 5 raised to what power will give me 25? 2. So the answer to this log function is the exponent. So number 2, I'm looking for 2 to what power will give me the number 8? So the answer is 3. So a log is just another way of writing an exponential question. So number 3, what would the answer be? 1, because 6, which is the base, raised to the first power would give me back 6. What would be the answer to number 4? 2, because 4 squared is 16. What about number 5? 2 again, because 7 squared is 49. Okay, number 6 is a little bit tricky. There's no base written there. Go back up to the note, because when no base is given, use 10 as the base. This is called common log. It's the button that's on your calculator. See log right there? That means that the base is 10. Just like in a square root function, do I have to tell you that the index is 2 for square root? No. So usually it's just not written there. So it's just not written here. So this is just asking you 10 to what power is 100? The answer is 2. And if I actually type the log of the number 100 on my calculator, log of 100, it'll tell you the answer is 2. Take a minute and try 7 through 15. You're evaluating these log functions. 1? Oh. They might go home because they'd use any excuse, but. All right, so try these. You're evaluating logs. It's kind of cool. It's a new function that you haven't seen before. Because of your exponential knowledge, you can kind of just do it, hopefully. Well, you don't need the log button on these because most of them have a base other than the number 10. You can only use the log button when it has a base of 10. Oh, that's coming out really nice. Oh, you guys all picked the first one. So 3 is the base. 3 to what power is 27? 3 squared or 3 cubed or 3 to the 4? 3 times 3 times 3, right? So that would be 3 to what power? Mm-hmm. It's brand new. So you might, oh, it's easy to take that. You could, or your unit test is going to override it anyway. It's better. So this was just kind of where people were at on Friday with traffic. So if you get stuck, this is what you're thinking in your head. 3 to what power is 27? 5 to what power is 125? 8 to what power is 64? The base of the log is the same as the base of the exponential question you're asking. So it's called the base of the log. This is called the base of an exponential expression. It's the same. Just like over here, the index of your radical is going to match the power over here. The 3's are the same in both places. Here, the 5's are the same in both places because they're inverses of each other. Take like 30 more seconds and try 7 through 15. And then I'm going to put this aside, look at your quiz, and see if we could wrap up the bouncing ball problem. And I don't know if we'll have time today or not to do the resource page too, but the more we kind of front load into our week, the more time we have to kind of review and practice it instead of still learning. All right. 753, 3 cubed is 27. Number 8 should be 3. 5 cubed is 125. Number 9 should be 2. 8 squared is 64. Number 10. 2 to what power is 16? 4. 11 to what power is 11? Mm-hmm. 3 to what power is 9? Mm-hmm. Here's a tough one. 2 to what power is 32? You can count them on your fingers. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it's 2 to the 5th power. All right, the 10 is missing, so I'm going to write the 10 there. 10 to what power is the number 1,000? 3. And then 5 to what power is the number 1/5? So that's a negative exponent where it does the reciprocal. So everything for logs, you need all your information from exponential. So we will do a mad minute tomorrow where I give you another set of problems just like that. I'm writing it down. A log mad minute. And you'd be surprised. It's really just another operation in your math kind of arsenal. Who took the SAT or PSAT this fall? Does anyone remember seeing a log? I don't know if they put logs on it or not. I think log is more of a pre-calculus topic. Yeah. I don't think we had done factor. I don't think you had done factoring by October. So it was like traded stuff. Like, there was a lot of geometry. Well, it's called an aptitude test, so it's taking your skills. The ACT, if you have the option as juniors to take the ACT is a lot more focused on skill. You have to do 60 questions in 60 minutes. The SAT is more kind of critical thinking, using your skills in a new way, and each question takes a little bit more critical thinking. I recommend trying to take both as maybe a junior or senior. I think you have to travel to do the ACT though. Maybe they took it in Berlin. So that's Well, no, so ACT has one math section, the 60 questions in 60 minutes, and it has one science section, which is a lot of reading tables and interpreting data. And then it has like a math and an English and a reading. SAT has basically like the 2 English sections and the 2 math sections. So you get just a math score and just an English score. Okay. Could you take out the quiz that I just gave back? Just wanted to show you the answers so we could, somehow I lost my, oh, this is math. Well, might not be able to show you the answers. Darn, I thought I had my answer key to the quiz. Might have lost it. I don't know. I wanted to go over it though. So, just real quick, the answer